Hello all. This is a session where we are going to learn this concept of adjacent angles. A very important concept, a very interesting concept, and a very easy concept. So when all three come together, there is absolutely no reason why we should delay learning. Here we are. So the concept of adjacent angles is what we are going to study in today's session. Well, we all know what an angle is. I'm not going into the definitions of angle, presuming that the viewers are conversant with what an angle is. Well, it is when two arms, as you know, when two arms, it can be something like this. When two arms meet or intersect, what we have in between is the angle. So in this case, AOB, you know, is an angle. AOP is an angle, BOP is an angle. So there are quite a few angles that you can see in this setup. We are going to study these two angles, angle AOP, which we have just named as angle 1. So here we are, angle AOP, which is angle 1. We have just named it angle 1. And angle BOP, which we have named as angle 2. Why angle 1 and angle 2? Just for easy reference. Instead of calling angle AOP, we'll call it angle 1. That's it. That's the overall reason. No other reason as such. So these are the two angles. Now, let us familiarize ourselves, if we already are not, with some of the terms associated with angles. Now we have something called a vertex. So where the two arms meet or intersect, that's called the vertex. So, well, let me hold this in one hand so that my other hand is free to show you where the vertex is. This point is the vertex. So this is one arm, this is the other arm, and the two have met here, and that's how this is the vertex. So in this case, O is the vertex of quite a few of these angles. For angle 1, which is angle AOP, let me know what the vertex is. Well, you are right. Angle A, angle 1, the vertex is O. And let us also have a quick look at the vertex when it comes to angle 2. So angle BOP is angle 2. Angle BOP is angle 2. And once again, the vertex is O. O. So once again, we have O as the vertex. Now let's come to the arms of these angles. Well, coming to these markers as I have in my hand. These are the two arms, in this case, two arms. There could be line or line segments. When they meet or intersect, we get an angle. So the lines, the two lines or the two line segments, in this case, this and this are the arms. So when it comes to angle AOP, which is angle 1, you would appreciate that AO and PO are the arms. AO and PO are the arms. An angle would always have two arms, not more, not fewer. Two arms, one vertex. Now when it comes to angle 2, let's quickly look at what all arms we have here. We have BO and PO. BO and PO. So we have completed this table, and from the data that we have derived, we'll make a few inferences and we'll use them to establish a few things. Let's have a look. So between angle 1 and 2, what is common when it comes to the arms? Which one is the common arm? As you can see, we have PO in both angle 1 and 2. So it's easy to see, easy to establish that the common arm in this case is PO. So PO is the common arm. You have this arm in both the angles. As you can see, AOP has AO and PO. BOP has BO and PO again. So PO is common in both of them, and that's how we call this arm PO as the common arm. And what are the non-common arms? Obviously, something which is not common between them are non-common. So we have AO and BO. Now, I'm sure you are quite familiar with something called common, even in practical life, in everyday life. Well, you stay in gated communities or you stay in layouts where there is a children's park. Children's park are common areas, aren't they? You stay in an apartment, in a building, and you have the lift which takes you up or down. So A lift is a common property which is held by the residents of the layout. Your bedroom, your kitchen, these are your personal rooms or belongings, but the children's park or the lift or the elevator, these are common areas. So over here, what is common? PO is common. What is non-common? AO and BO. Now, after we have established all of these, let us study a few things for angle 1 and 2. Well, we have been studying for angle 1 and angle 2 anyway, but let us now make some conclusions based on what we have derived. So, for angles 1 and 2, I'm talking about angles 1 and 2. For angle 1 and angle 2, they have a common vertex. Yes, you can all see. And the common vertex is O. Yes. They have a common arm, and that is PO. Well, these two are so very easy to establish. And the third one, it's already here. We're just going to frame the statement, call it. Well, these are already framed. And the third one is what we are going to frame. Now, what we are going to say here is that the common arm that is PO, it lies between the non-common arms. In this case, it's AO and BO. So these are the three conclusions that we can draw. Again, we have a common arm, which is PO. We have non-common arms AO and BO. And what conclusions? This is summarizing everything that we have seen across this figure and this table. They have a common vertex O. They have a common arm PO, and the common arm, which is PO, it lies in between the non-common arms, which means one non-common arm, which is AO, would lie on the left of this common arm, and the other would lie on the right of this. So PO comes in between. When all of these three conditions meet, angle 1 and angle 2 are said to be adjacent angles. Full stop. Nothing more, nothing less. So only when all three conditions meet, mind you, all three conditions must meet. So how do we check? We check for the first one. If it is right, if it is meeting, we go to the second one. We then go to the third one. If the first condition, let's say, itself has not met, then we don't have to check for the second and third, because all the three conditions must meet for the two angles to be called adjacent angles. In the next video, or in the next frame rather, we will see some examples and we'll try to establish if two given angles are adjacent or not.